Okay, part 3, linear regression. Our second example was we had 10 students and we had weekly TV hours and GPA for those 10 students. Now again, these 10 students may or may not be typical, but any conclusions we're going to draw on the basis of their being typical. So we'll go from there. Our scatter plot, remember, looked something like this. Some degree of negative association, but nowhere near as strong as the previous example was. And we ran our calculations and we got our correlation to be negative 0.628367. That's a little better as far as accuracy goes than the previous example. So, although we could do this either way, unlike the previous example where it makes about as much sense either way, here it makes sense to use TV hours to predict GPA, maybe not so much sense to predict the other way around. So I've planned accordingly by calling TV hours the logical thing to predict with x, the horizontal, the explanatory variable, and GPA, the logical thing to predict y, the response, the vertical, the thing that comes out. So we'll do weekly TV hours predicting GPA, and consequently we're talking about the least squares regression line of GPA on weekly TV hours. It'll look something like this. So I've planned accordingly, as I said here, and there's our data once again, and we've got everything ready to go here. We added up the x's, and we got 138. We added up the y's, and we got 30.2. We computed the SSX and got 397.6. We computed the SSY and got 3.596, all in the section 16 videos. And that's all we need going forward, because from here the calculations are a little weirder, but they're simpler. So again, where's our formula? Way back up here someplace. Y hat equals mx plus b, where m is r times the square root of SSY over SSX. And now we'll just do it. So there's our r from the previous page, and there's our SSY, and there's our SSX. Now again, the SSY is the 3-something, the SSX is the 400-ish. And again, 3 divided by 400 is a very different creature from 400 dividing by 3. If you're predicting a GPA which isn't particularly close, it's because that may be a somewhat atypical dot. But if you're predicting a GPA of 16 or negative 48, that's a mistake in the formulas. Anyway, r times radical SSY over SSX is negative 0.059759. And then from there, we can predict, we can figure out RB, which is y bar minus m x bar. Now again, we don't exactly have y bar and x bar, but we do have the sum of the y's divided by 10 of them, and there's y bar. And we do have the sum of the x's divided by 10 of them, and that's the x bar. So y bar minus m x bar. Watch the signs. Minus a negative m. You're adding here. 3.8447. So there you go. Again, I don't know why I did this in the b plus mx form, but there it is. Negative 0.059759x plus 3.844. Or back to front, either way. I do know why I've done this. It's because when I go to type it into my calculator, I can just call it back up and change the bit on the end rather than having to type it again. So there is our line in numerical form, and then when we go to graph it, it looks something like this. Now again, this 3.844 would be the y-intercept, which is, back here in 0 territory. I want to say about here. So if I were horizontally at 0, and of course I'm not, then the line would be at about this height, which presumably is 3844. Seems about right. Horizontally at 0, vertically at 3844. But of course, there's nothing in that territory. They only go from 4 something to about 25. 4 actual to 25. Notice because the correlation is lower and the heights, the dots aren't particularly lined up, the heights of the dots aren't particularly close to the height of the lines, so our predictions will not be as good. Some of them will be good. For this 15, it looks like it'll be very good. For the 20, not so much. And again, I totally missed this dot when we were talking about it earlier. There are 2 different realities at 20. At least it looks like. I'm not seeing it. Maybe that dot is just a mistake. No, it's definitely there. But I'm not seeing, oh, it's 21. Okay, it's close. So this is 20 and this is 21. My mistake. So we can go to do our predictions. Plug the x's in and plug the x's, yeah, well, third time's the charm. Plug the x's into that and we can make our predictions. So for a month, let's blow this down a hair. There we go. For a month in which we sold 14, for a month, try again. For a student, for this particular student who watched 14 hours of TV a week, the reality was a GPA of 3.1. If we plug 14 into this, subtract, add, well, 3844 minus that times 14, we get 3.1. Whereabouts is that? 14 is, it must be this one here. So the reality is 3. No, it can't be that one. It's this one. So the reality is 3.1 and the prediction is 3.0. The dot 3.1 is a little above the line, 3.0. So if we plug in 10 hours of TV a week, the reality was 2.4. What was our prediction? So 3844 minus that times 10, and we get 3.2. So this is this dot, obviously. The reality is at height 2.4. The prediction is up here at 3.2. Well, again, when the dots are not particularly lined up, even the line that best fits the dots is going to end up with some of them far away from it, and this is one of those. Outlier, if you will. Nevertheless, overall, it predicts better than it would for any other line. It's just that this dot, this particular dot, is one of the sacrifices we make. Moving on, let's go to the end here. We've got 21. So if we plug in 21 into our formula, that minus that times 21, we get 2.6, but the reality is 2.5. This is the other extreme, right? This is the other outlier. The reality is up here at height 3.5. The line is underestimating at height 2.6, whereas, of course, this one was overestimating. Well, there's going to be balance, of course, because this is all based on mean and standard deviation, which are about balance. If there's something way off the beaten track on this side, then there's probably going to be something way off the beaten track on this side to balance it out. Or a lot of little stuff, Balance can work all kinds of ways. So that's the reality. Notice for some dots, the dot is very close to the line, so the vertical distances are pretty close, like the 14 here. For others, like the last 2 we looked at, the 10 and the 21, it's a little further off. On balance, the predictions are not so great because the dots are not so lined up. Now again, this is for the data we happen to have, but it does put you on somewhat shakier ground when you go to predict for other horizontal locations. Now again, you can do this in all kinds of ways. You can plug in some reality that we don't necessarily have here, like, 17. Run 17 through our formula and get out, whatever height this is. Or we can extrapolate, we can plug in things less than 4 or more than 25. As far as extrapolation goes, I've made the distinction here between wisely, foolishly, and extra special foolishly. If you plug in 30 hours of TV a week or 28, then maybe it's not such a wild extrapolation. The trend might continue over here to 28 horizontally. But if you go all the way over to 40, which I think is what I do, 40 would put you where? Let's see, this is 20. So 40 would put you about that far again. We'll see 15 more. So 40 would put you about this far again, which is what, maybe about over here? This territory here? So that's a little silly, but let's check it out. If we plug in 40 hours a week, that gives us a GPA of 1.5. But bearing the numbers we have here, 40 is very far off the beaten path here. Why would the trend hold that far from the dots we have? So, yeah, that's a little foolish to extrapolate that far. Will the pattern continue to hold that far? Why should it? It's a bit of a reach. Now, again, you could be predicting the height of King Kong from his age, or vice versa, using other gorillas, but we are talking about something fictional, so who knows whether that pattern would continue to hold, even for a really big, old gorilla. So we're not even on that kind of ground here. Or you could predict extra foolishly. If somebody watched 90 hours of TV a week, well, if you run 90 through the formula here, if you watch 90 hours of TV a week, you're going to predict a GPA of negative 1.5. Of course, that's impossible. You can't have a negative GPA. So if we were horizontally at 90, that would put us vertically at negative 1.5, but that's meaningless, of course. Can we do worse than that? Sure. Let's give it a try. If we plug in 200 hours, then run 200 through our formula, and we'll get negative 8.1. Why is this fundamentally stupider? Well, you could watch 90 hours of TV a week, it's just that what we're predicting is impossible. On the other hand, the input here doesn't make any sense. I mean, run the numbers, 24 times 7. You literally cannot watch 200 hours of TV a week. It's impossible, not without time traveling. So, yeah, here even the input doesn't make any sense, never mind the output. So, these are all examples of foolish extrapolation, but some are a little bit more foolish than others. So there's our third example. And now I believe we're all caught up through sections 1 to 19. So that just leaves 20, 21, and 22, I believe we're committed to doing. And we'll finish off those videos as we go.